Hello students, I have as here Citra 15 algorithm and complexity analysis. So let us conclude the algorithm that we started the other time, and let us briefly discuss about the general algorithmic design techniques. I'll call it algorithmic design techniques. As I said, there are several ways to design an algorithm. It depends on the individual, the programmer, but the only thing is that all of us must have to achieve the same answer. We must achieve the same answer. So for us to design an algorithm, there are some techniques that you can use. One is by the use of natural languages. Natural languages. And what is natural languages? Natural languages are English expression. English expressions is what we call natural languages. Just like Igbo language is also a natural language, French language is also a natural language. So while you are designing your algorithm, you can use English to express the algorithm. Now once you are doing that, what are you writing? You are writing an algorithm. You are writing an algorithm. And this algorithm will be in English language. Then the second one, you can use pseudocode. You use pseudocode to design an algorithm. That's another technique that I can use in designing an algorithm. So for pseudocode is a combination of natural language, that is English language, of natural lang, and programming constructs. So in pseudocode, you're using a combination of natural language and the programming construct. So it is just a near code to the programming language that you want to use. So that's another technique, another algorithm design technique that you can use by using a pseudocode. And when you use a pseudocode to design an algorithm, that means it's just very good for you because you are just getting to the codes. So it's a good tool. And you know what they call pseudo? Pseudo means to imitate, and then the code, call it that, to imitate codes or a kind of metacode. So pseudo means to imitate, to mimic something. So you are mimicking what? What are you mimicking? You are mimicking the program construct. That is why I said it is a combination of natural language and the programming construct. Then the last one, which is number 3, is when you use a flowchart. You can use a flowchart using the flowchart symbols: begin, processing, input, decision, connectors. So if you are using all these things, we call it, you are using flowchart. So use flowchart to describe how the flow of programs, how they have been from one compartment to another compartment. So you can use a regular language, you can use pseudocode, you can use a flowchart. But the problem of flowchart is that it is very large. Sometimes it is very, very large. So when you are using flowchart, you see that as you are drawing, it can take up to 1 page, 2nd page, even 3rd page, depending on the problem you are solving. So that's it. So For algorithm design techniques, we use natural language, we use pseudocode, then we use flowchart. Then we now go over to complexity analysis now. Go to complexity analysis. And in complexity analysis, let us talk about time and space. Time and space trade-off. Time and space trade-off. We say that the best algorithm, hence best program to solve a given problem. It is just one that requires less space in memory, and takes less time to execute its instruction or to generate output. So best algorithm, have a best algorithm, best algol. Best algol implies best program. Best program to solve a particular problem which requires less space in memory, and also takes less time to execute. But in time and space trade-off, it is not possible. So in practice, it is not always possible to achieve both of these objectives. Having a program that will execute, give you the output with less space and also less time to execute. So one such approach may require more space but takes less time to complete its execution, which is true. Thus, we may have to sacrifice one at the cost of the other. You may have less space, but it will take time to execute, or you may have less time to execute and then more space in the memory to occupy more space. So these are what our algorithm can take. So therefore, if space is a constraint, then we have to choose a program that requires less space. And use a program that requires less space at the cost of more execution time. And other than that, if time is a constraint, then we have to choose a program that takes less time to complete its execution of statement at the cost of more space. So you cannot have the two at the same time. You cannot have a program, an algorithm, which is the best of program that gives you the output with less space and also less time to execute. So for time and space trade-off, that means you are taking one in place of the other. So either you are taking an algorithm that takes less space and takes more time to execute, or the one that takes less time to execute and then we now have more space in the memory. So that is what we call time and space trade-off. You are trading this one in place of the other one. You are trading less space in place of higher time, or you are trading less time in place of higher space. So you can choose any one of them. And what are these types of trade-offs? We now have types of trade-offs. We have up to 4 types of trade-off. The first one is what we call lookup table. Lookup table versus recalculation. So in lookup table versus recalculation, it means an algorithm involving a lookup table in an implementation can include the entire table. You can have a table which we call the lookup table. So assuming that this one is a table containing some attributes, then you now have the items in these columns. This table reduces computing time. It reduces computing time. It reduces computing time but increases the amount of memory needed. But it increases the amount of, let me just put it in short, amount of memory needed. So when it reduces the computing time, but increases the amount of memory needed, or it can compute table entries, or you can make it like this one. Now we have this table because you have the items already there. So you now see that the computing time for you to multiply, let's say you have 2 times 2, 4 times 4, and so on. You now see that it is drastically reduced. So in essence, when you are computing 2 times 2, 3 times 3, you are not, what you're doing is just to increase the computing time. But if it is in table format, then it occupies more space, but the computing time is less because it does not need to calculate and recalculate. It has been calculated already. But if we are calculating it at the same time, that means that the space will be reduced, but the problem is that the computing time will be what? Increase. We call it lookup table versus recalculation. Then the other type of trade-off, is what we call compressed. That's the second one. We have compressed versus uncompressed. Compressed versus uncompressed. So for compressed versus uncompressed, you can compress your data. When you compress your document, like you have zipping, you can use zip, WinRAR, and so on and so forth to compress your document. So when you compress, that means that the space, you have saved space. When data is compressed, you are saving space. But when it is uncompressed, if it's uncompressed, means it's scattered. When it is uncompressed, it is scattered. So in that case, you are not saving space. But when data is compressed, when your document is compressed, your data is compressed, the problem is that it takes more time to execute or to unroll. It takes more time to execute or to unroll than when it is uncompressed. When it's uncompressed, it takes more space. But the problem is that the good thing is that during the execution, it does not take time to execute. Whereas in compress, you are saving the memory, but during the execution, it takes more time to execute. You can try it when you compress your data or when you compress your document, so that it saves space. But when you want to unroll, you want to disclose what you have in your compressed file, it takes time. Like WinRAR, it takes time. Like which other one? There are many of them.